Here to talk about feeding the future, please welcome to the stage founder and creative scientific director of Future Food Studio and SingularityU Canada Future of Food faculty, Dr. Irwin Adam.
All right, well, I'm going to share with you a little bit about our future of food. I'm going to start off with bringing us all to the dining room table, right? We all eat. We all know food. We all share food. Food is the way that we tell our stories. It's the way that we share our histories. It's actually the original social media. Food is also the way we create one another. When we feed each other, that food becomes our hair, our skin, our nails, our energy. And so food is a very personal experience, but it doesn't stop there. Though food transforms us as individuals, it also impacts the world at large. Everything we eat has broader implications on a global system at a global scale. We're approaching a very great challenge in our near future, where by 2050, we'll have grown our population by another 3 billion people. And we need to figure out ways to feed them. And not only to feed them food, but also to make sure that they're receiving the best quality food that they can receive while protecting our world and our climate. This is a challenge that we've seen once before. In the 1960s, we went through the Green Revolution. The problem at the time was we had a rapidly growing global population, and 1 billion people were at risk of starvation. And so plant scientists, agriculturists from around the world came together and created new varieties of grains and rice that could grow faster. They could grow in higher density. We could be much more productive with the way that we made food. And this worked, right? We managed to save 1 billion lives. In fact, pictured here is Norman Borlaug, the father of the Green Revolution, who was awarded the Nobel Prize in 1970 for doing just that. But it didn't just stop there. Though we did something great, we also didn't foresee a lot of the impacts that these technologies would have. In order to grow food more intensively, we needed synthetic chemical fertilizers. We needed more water. We needed to transform our land in ways that have been irreversible, and that has led us to our current state, where though we make enough food for 10 billion people on an Earth that has 7.5 billion people, there's still about 1 billion people who are hungry. We produce so much excess food, yet we waste almost 1/3 of it. And that's a global statistic. In Canada, it's much worse. We waste over 50% of all food produced, right? So that's an environmental waste of land use, of chemicals, fertilizers, human hours, and ultimately, dollars are wasted. So when we think about agriculture, this is kind of a simplified schema of where the contributions to greenhouse gases come from in agriculture. The main sources we have are really from ruminants, such as cows, producing methane. And then the second source is really from nitrogen that's being applied to the land in the form of fertilizers, right? So we have to apply lots of fertilizer to the ground in order to get things to grow up. But then that nitrogen gets transformed into nitrous oxide that then behaves as a greenhouse gas. So unlike other industries which produce CO2, in agriculture it's predominantly methane and nitrous oxide. So when we put this in the context of all greenhouse gas emissions, right? First of all, we all think of energy as a huge contributor, which is true. And then many folks would say, yes, transportation is also a big contributor to greenhouse gas emissions. But what we don't realize is that agriculture is pretty much equivalent to transportation. And the majority of that is really coming from animals. So how many people here have driven a Honda Civic? Right, so the Honda Civic, I believe, is Canada's #1 selling vehicle for the last 21 years, so a few of you have. So I like to put meat products in a context of kilometers driven by a Honda Civic. So these are the number of kilometers equivalent in carbon emissions for the production of 1 kilogram of beef versus other meat sources. And so you can see when we look at animal proteins, the emissions associated and the environmental impact associated with animals such as beef production, these have far greater implications than, say, eating lentils. Beef at 176 kilometers, lentils at about 6 kilometers. So if we're going to feed the next 3 billion people who are going to join us here on the planet Earth while maintaining climate change goals, we're going to need to produce food differently, and a lot more of it. What's amazing, though, is today, food has really become a nexus for all of technology, right? We're seeing some of the world leaders in fields such as artificial intelligence, robotics, automation processes, blockchain, all converging on the food supply and the food system in order to make it better. And food really starts with individuals, right? About 25% of our global population derives its primary source of income from agriculture. This is a woman, Rosana, who I met with in Aregua, Paraguay recently, and she's a subsistence farmer just outside Asunción, which is the capital of Paraguay, and leads a little co-op there of about 2,000 farmers who have plots of land that are about the size of this stage. Right? So they're not very big, but those plots of land are providing the complete income for those families for that year. And so when they go about growing things, they often have to take loans out in order to procure the fertilizers and the seeds and all the things they need to grow their crops. But often they find themselves in situations where their crops fail. And what happens in that situation is they are no longer able to repay those loans. So some of the questions we were discussing with her were, what could be used to mitigate some of those problems? Well, the amazing thing is a lot of these technologies already exist. One of the big challenges they have in their fields is they don't know how to identify plant diseases. Well, what happens when suddenly we have mobile plant disease identification systems, right, such as this one from Plant Village, where suddenly a farmer, a grower, can just go and take a photo of the plant that they have in their field, and we can identify early on what the problem might be, whether there's an infestation or a fungus or whatever the disorder might be. That can then quickly be treated, thus saving the crop and thereby saving income for that family for the year. Another big question for these farmers is an understanding of their soil quality. They have no clue what's going on with their soil, right? When we go to big farms, often we're doing soil testing and an analysis and understanding what the different nutrient profiles are, and then we're able to apply fertilizers as needed. With these folks, they just go and throw whatever fertilizers they might have, right? So that's both a huge cost center financially, but it's also an environmental concern because they're applying fertilizers without really considering the impact of them. So small mobile technologies such as this near-infrared spectroscopy system allow these types of farmers to basically have a unit that they can just plop on the soil and get a readout, right? So having one of these distributed between those 2,000 farmers of the co-op can suddenly enable them to grow more, better, and faster. So technology, though, is important at the small scale. We also are starting to see how technology is being incorporated within larger scale agriculture, right? So we have these kind of satellite-guided tractor systems, right? So being a farmer today is very different than what many folks might imagine, right? Often tractors are linked through GPS, receiving satellite coordinates, and that's how producers are plotting their paths across fields. Right, so in this case, you can see they've mapped out their plot of land, and suddenly the route is created automatically that then drives that tractor up and down the field. And so suddenly this enables us to be a lot more productive and a lot more efficient in the ways that we use our equipment and our land. Here you can see how farming in some ways is being transformed into a computer game. Right, so in this video, you can see how a farmer has an entire farm plotted out with all the different crops on each section of land, and suddenly is able to monitor what's going on in each of these. And then looking at what the needs are of each of these plots through sensing data can actually start to subcontract out labor to some of these plots. So suddenly you can see we've zoomed into this plot. it needs something to be done. A contractor was selected, and you can actually see there's a tractor now in real time going across the plot of land. And through that, we're starting to get an understanding of how fertilizers are being applied. And through other satellite technologies, we can actually understand what the context of is that land. And suddenly, we can then apply with greater precision the fertilizers that we might need. As we start seeing robotics and automation join us in the field, we're finding we can have labor that works 24/7, that can be a lot more precise in the work that it does. Here you see a system that weeds, right? Instead of going to the field and disrupting the topsoil, we can just weed with a single unit. Here from the University of Sydney, this is a picker device that can pull individual fruits and vegetables. So we're starting to see a lot of robots and drones start entering the farmers' fields and orchards in order to automate and bring greater capabilities to what an individual farmer can do in their field. But what happens when we even go further, right? We know we exist on a planet that might be very compromised due to some of the decisions we've made over the last century or so. And in one field, we've seen that there's been a huge collapse of bee populations, right? And we know bees are quite important for agriculture and for food production. So in response to concerns such as this, we have this group from MIT that have developed these Robo Bees, right? So what would it mean if suddenly we had robotic bees that could then help us with pollinating all the plants? What would happen if we just released them out into the fields and suddenly they could help us revive systems that we may have otherwise destroyed? So the new farmer has to reimagine how to apply tools in the field. But we also need to consider what we grow. So it's not only how we grow things, but it's also what we're physically growing. And so there's a lot of work being done around understanding what an ideal plant might look like, right? What would be the best possible thing to put in the ground in order to feed our people? And so, I think you might be familiar with how a plant works. There's kind of leaves on top and there's roots in the ground. But something very important about how those roots function is that they actually sequester carbon, right? So there's a lot of research being done today in understanding how our crops can sequester carbon within the soil. And kind of the bigger and the deeper those roots go of those crops, the more carbon can be sequestered. And specifically, that carbon is being held within a compound called suberin, which is basically cork that lines those root systems, right? So the bigger those roots, the better for carbon sequestration. And so there actually is a plant that has been developed over the last while called kernza. Kernza is a grain that has been crossed with grasses and has a very special characteristic where it's a perennial grain, meaning it's coming back year after year. So this is a crop that can be planted once and then can be reharvested for up to 5 years. What's even more incredible about this crop is that it has an extraordinary root system, right? So if you look at how these root systems develop, these are images going from September to June in growth. You can see a more conventional wheat on the left, which you can't even see its root system until it's developed in June. And this is in comparison to a perennial wheatgrass, such as kernza, that you see on the right. And so when you look at these root systems, it's incredible. They're going well over 2 meters deep into the ground. And again, that's another way for us to pull CO2 and carbon out of the atmosphere and into the ground, while also promoting better agricultural methods and techniques, because suddenly we don't have to disturb the ground so often in order to produce grains. So there's breeding programs that are used in order to create these new varieties of crops that we want to develop. But we also have access now to gene editing technologies. And of course, there's a lot of hesitation around genetically modified organisms, and that is a huge discussion. I think it's difficult to say that GMOs are good or bad. They have served a function to date, but we also are on a trajectory where our planet is changing very rapidly, right? And the breeding programs we have to date, they often take quite some time to develop these new varieties. When we're trying to, the Ag Canada is working to develop a new wheat variety. This is a process that can take 7 to 15 years, where until there's enough seed to actually put in the ground and generate real crops. So there are ways for us to short circuit this. And part of that is using gene editing technologies such as CRISPR Cas9 systems. And a very high-level overview of how it works, essentially we're able to target specific areas within the genome of the plant and insert genes of our choice into those in a very clean way, and then we can grow up crops made from those transformed cells. And so, this has been done in many ways for a long time. Here you can see a plant that has been transformed with a glowing protein. That's not particularly useful, but that could be an indicator of something else. So, the burger. Many of us here have witnessed over the last couple of years a huge transition in what's going on in fast food, right? Big companies now, large, quick service retail companies are starting to recognize a movement towards plant-based eating. And this is being driven a lot by consumer needs and consumer demands. And so we're starting to understand that not only do we need to, reimagine the ways that we're growing things, not only do we need to reimagine what we're growing, we also need to reimagine what we're eating and what we're consuming. And so we're starting to see a large movement towards more plant-based eating. So we have multiple companies now that are promoting burgers that are made from plant-based materials and that are designed to give you the exact same mouthfeel, the same experience of eating a regular hamburger, but from something that has no animal products in it. When we start looking at how we can further diversify our protein sources, the World Health Organization has suggested that we might include insect proteins. 2 billion people in the world today have insects as part of their daily diet already. Right, so what does it mean if here in Canada we start to integrate insect proteins within our diets? Right, what does it mean to supplement part of our protein consumption through insects that have a much smaller footprint, environmental footprint, than, say, larger animals? Again, continuing on this thread of new proteins and the things that we eat, we're starting to see a huge emergence in the area of cellular agriculture. Right? So contextually, right, we've been doing about 70 years of tissue engineering research trying to understand how to fix human beings. Well, now over the last 2 decades, we've started to see the application of that research to growing steaks. All right, so what does it mean suddenly instead of growing hearts in the laboratory, I can start to actually grow a steak? And this is a field where Canada can really flex, right? We are a huge agricultural economy, and we should be one of the leading players in the world in these fields, but we're not. And this is really a space where we have a huge opportunity right now to lead the way into the future, because it doesn't really make sense that the folks who are making these products are based in San Francisco and New York predominantly. And that takes us to kind of this last area around personalized food and the ability to start growing foods that are actually responsive to the things that we need, right? Not all of us have the same nutritional requirements as each other, and not all produce is made equivalently, right? So if you go to the grocery store, you could have 2 heads of lettuce next to one another grown in different ways, and those could actually have quite different nutritional profiles. And so we're developing newer systems now that can tailor the nutritional and flavor content of foods, right? So suddenly imagine you have a certain deficiency, let's say a B12 deficiency, and you prefer, a saltier lettuce. Suddenly that's something that can be programmed and actually grown. So on a small scale, things that we're seeing pop up in the home environment are things like this food computer, right? So suddenly you have a system that can download recipes for growing plants, fruits, vegetables, whatever it is you're trying to grow in the home, and can then tailor how those plants grow in front of you, right? And that is through a mixture of different nutrition profiles, lighting, and through humidity and other temperature variations. But again, it's incredible that we're now starting to have this power at the micro scale. So this is something that's connecting up and down, right? It's something that can be on our kitchen table, but also can be driving and feeding an entire country. laddering that up to how we can connect these dots is really a lot of the work that's happening around personalized food and personalized medicine, and that's around continual monitoring systems. So what does it mean to suddenly have nonstop information about your current physiological state, right? And we've already seen the advent of things like Fitbits. You know, there was a lot of uptake in that world. But what happens when suddenly I can actually know, what my vitamin levels are, electrolyte levels are. I can know exactly what's in my blood chemistry and then tailor the things that I'm eating to that chemistry. So suddenly when you show up at a pressed juice shop, and you're making a decision to buy pressed juice for 14 bucks, instead of choosing based on color, you'll be choosing based on something that you actually need, right? So what happens when we start to connect those dots? So I'll tie this up with a representation of how our different behaviors will impact our ability to meet our global climate change goals. And so on the left side there, you can see kind of the projection of environmental strain. So this is the strain that's going to exist on the Earth if we just continue as is. But then in the first column, when you look at loss and waste, if we reduce our waste by half or reduce our waste by a quarter, we start to see a huge alleviation towards what our global climate change goals are. When we start applying technology, similarly, we start to see that reduction happening. But where you see the biggest reduction of environmental pressure happening is when we change our diets, right? And this is very important. When we start to re-examine how we consume on a daily basis, and we actually make those changes, we can transform what our tomorrow looks like. And so in this case, this is a study that recently came out in October. The examination was around what happens if the world's population transitioned to a more flexitarian diet, right? And what does that actually mean? Well, for people in Canada and the United States, that means 90% less pork products, about 70% less beef, about 50% of the eggs consumed, while tripling and quadrupling legumes and other pulses in order to accommodate those protein sources. But suddenly it actually makes it possible for us to hit our global climate change goals. And then when you combine technology, changes in behavior, and reductions of waste, suddenly we become very much more in a better position in order to transition over the next 30 years. So I'd like you to think about your dinner table as not only a place where you gather to eat. This is also a place where you are negotiating your future. It really is an intersection of technology and choice. Thank you very much.